Hey, this is Tuesday, the second Monday this week.
Hi, Julia.
Someone referred to Tuesday as the second Monday of the week. Do you feel tired? Thanks. Who feels more tired on Mondays compared to Tuesdays? Who feels more tired on Tuesdays compared to Mondays? All right. Hello, Sawyer, Johnny, and Julia. I got to see Sawyer and Johnny yesterday. All right. Least common multiple. Back in 5th grade, you learned back-to-back greatest common factor and least common multiple. And for some of you, you got those confused for a few weeks, but not now because you're older and wiser. Give me a quick summary. You got 20 seconds to explain how to find the greatest common factor by prime factorization. I give you two numbers like 6 and 8. How did we find the greatest common factor for those two numbers? By using prime factorization. What did we do with the prime factors? What was the rule? Once we had them down to their primes, how did we determine the GCF? Jade?
You find which numbers are common in both, and then you multiply.
Okay. You find which numbers are common in both, and then you multiply them. And the key was, if you had 3 2s down here for one number and 2 2s in another number, how many 2s would you combine? You had 3 2s here and 2 2s there. You would use 2 2s because they shared, they had in common 2 2s. You with me? Okay. The rules for least common multiple, also we're going to factor things out to their prime factorization, but I'm going to go right to the highlights. I want you to go to the bottom of page 186 at the end of example 1 and read this sentence with me. Ready? Write the product of the highest power of each prime number in the prime factorizations. Okay, keep your eyes there. I'm going to read it again. You can read it to yourself. Listen to what it's saying. Write the product of the highest of each prime number when you're done with the prime factorization. And the third reading, ready? Let this sink in, Dominic. To find the lowest common multiple, you're going to write the product of the highest power of each prime number in its prime factorization. So for greatest common factor, we picked out which ones they shared. For least common multiple, we're going to find out the highest power and use that. Does that make sense? Let's look at the example they did. They were trying to find the least common multiple between 4 and 7. How many can do that in your head like right now? Go ahead.
1.
No, see? What did he do? He confused factors with multiples. So the first thing we got to do is reset our brains to factor products. They're smaller. Multiples are 7 times 1, 7 times 2, 7 times 3. So you're counting by that number. What's the least common multiple of 4 and 7? Many of you can do that in your head right now. 28. Okay? Everybody agree? If I was to write the multiples of 4, 4, 8, 12, 16, 20, 24, 28, 7, 14, 21, 28, first one you come to is 28. So they did a factor tree. By the way, what's 7? Prime. Use the highest power of 2. What's 2 squared?
4.
4 times 7 equals 28. Why did I use the 7? Listen, we're not using the ones they have in common. We're multiplying each of the prime factors to the highest power. So how do we get 28 using prime factorization? We have 2 2s. The highest power of 2 is 2 squared. You get it? Not quite, but do you get this one?
Yeah.
2 squared, 4 times 7. Okay, let's go to example 2. Now the numbers get bigger. 32, 96, and 120. They don't write out the factor tree, so I guess I have to. But read the middle of example 2. It says the same exact thing. Ready? This is your 4th reading, and some of you are looking at it and not really thinking about it. Ready? Write the product of the highest power of each prime number in your prime factorizations. The 5th reading. I'm trying to get you to memorize this. Ready? Write the product of the highest power of each prime number in the prime factorization. So you do 32, 96, and 120. Follow me here. 2 times 16, 2 times 8, 2 times 4, 2 times 2. So what's 32? It's 2 to the 2 to the 5th. I heard somebody say 4.
I did.
96. I always like to start with 2, so I'm done with that branch. But our times tables tell us that 8 times 12, 2 times 4, 2 times 6, 2 times 3. So we've got 2 to the 5th here. We got 2 to the 4th.
1, 2, 3, that's 5.
Times 3. 1, 2, 3, 4. And we got 3. You with me so far?
Wait, there's another 2
Yeah,
right
there's
next to the
another
6. Yeah.
What?
There's
Yeah,
another
there's
one
two
next to
next to
the
six.
6.
Oh, sorry. 120. 10 times 12. 2 times 5. 2 times 6. 2 times 3. So now what do we got? 2 cubed times 3 times 5. Okay, that's what they ended up with in example 2. This, that, and that, right? Now what did they multiply together? Read it again for the 6th time. Write the product of the highest power of each prime number when you do your prime factorizations. What's the highest power of 2 for all of these numbers when you got them down to their primes? What's the highest power of 2? 5. See 2 cubed? That's gone because there's a higher power of 2. 2 to the 5th. There's a 3 here and a 3 there. What's the highest power of 3 to use? 3 to... There's no 3 squared. So that's why they just use 3. What's the highest power? Listen, 5 is not even common, but it's one of the factors. So you got to use it. And to complete your memorization, your 7th reading of this rule, middle of example 2, goes like this. 7's number of completion in the Bible, right? So after we read this for the 7th time, Lauren will have this down pat. Ready? Write the product of the highest power of each prime number in the prime factorizations. I've done my prime factorizations. I got to use every number, but only to its highest power. So I'm going to pick out 2 to the 5th, 3, and 5. Becoming clearer? David. So if I multiply all these together, 2 to the 5th times 3 times 5, that'll give me my lowest common multiple for these 3 numbers.
How do you know what to select though as the 32, 96, and 40?
You select, you've got, one of your prime factors is 2, right? In this one, it's to the 5th. In this one, it's to the 5th. And in this one, it's cubed. Which one am I going to use? Which power of 2 am I going to use? I'm going to use the, what's it say? The highest power. Here's another factor, 3. Which one am I going to use? Here's 3 to the 1st, 3 to the 1st. So I got to use just 3 to the 1st. Another factor, notice I'm not saying common factor. I'm using all the factors when I get them all written down to their prime factors. but I'm only using it to the highest power.
So you use all of these to the highest power, the highest power?
All three of them. I'm going to use the 2, the 3, and the 5. And David, I guess for this one, the biggest thing is this guy's out. 2 cubed is out because I have a higher power of 2 to use. 3 stays in because the highest power is 3 to the first. And 5 stays. I have to use all the factors, but only use to the highest power. Yeah?
Yeah.
All right. Time to dive in, I guess. Your turn now. Number 1, page 187. What's the least common multiple between 6 and 15? I already know you can do it in your head, but you got to do the factoring. Dominic's like, I already know it's 30. Great. But we're not clear when they're not small, obviously. How do we get to that? 6 and 15. 2 times 3, 3 times 5. Am I going to use the 2?
Yeah.
Even though it's not common. I got to use all the factors. Am I going to use the 3?
Yeah.
I have to. To what power? There is no higher power, so just the first power. Am I going to use the 5? Notice I'm not looking for common factors. I got them all factored, and I'm going to use all of them to their highest power. 2 times 3 times 5 is 30. Didn't you know that going in, that the lowest common multiple is going to be 30? 15, 30, 6, 12, 18, 24, 30. You with me? I'm not sure yet. Let's do number 2. Between 4 and 20, you already know what it is. Tell me what it is, Jonathan. What's the least common multiple between 4 and 20? You know what he did? He did factors like Isaac did. I threw that eraser away that broke. Because in 5th grade, we just did this with regular arithmetic, and when they were confusing factors and multiples, I was going to throw the eraser at it. What's the lowest common multiple, Jonathan? 4 and 20. 20, right? We already know it's 20. How'd they get there? 2 times 2. I got 2 squared here. I got 2 squared there. And I got 5.
Oh.
Which, they're both 2 squared, so I got to just use 2 squared. That's the highest power of 2, and I got to use the 5. What's 4 times 5?
20.
20. We knew it was going to be 20. You still with me?
Yeah.
Except you're not writing it, Rachel. Number 3.
I did.
12 and 28. Now it's not so easy to do in your head, although some of you probably could. 12 and 28. What's going to be my least common multiple? Do my prime factors. I've got 2 2's here, 2 squared, 2 2's there, 2 squared. So I'm going to use 2 squared. You with me? I've got a 3 here. I got to use it. And I got a 7 there. I got to use it. So 4 times 3, 7. What's 12 times 7?
64.
84 is your least common multiple. Yes?
So you use the power, the separate number, like
Yes.
not.
Read it. Ready?
not just-
Write the product of the highest power of each prime number. Once you've done your factoring, you're going to use the highest power of each prime factor. Number 4. Okay, if you're not writing these like you should be, you have to do number 4. Everybody, we're doing the prime factorization of 24, 36, and 72. What's the lowest common multiple? And I thought I heard someone else just utter a factor.
Spencer.
Multiples, Spencer, not factors, multiples. Multiples, they get bigger. So 24, 36, and 72. The least common multiple, Spence.
Meow.
2 times 12, 2 times 6, 2 times 3. I got 2 cubed times 3. 3 times 12. What do I got here?
2 cubed.
2 squared
Square.
times 3 squared. Stay with me. You should be writing this. I haven't done 72 yet. Cindy's going to tell me which 2 am I going to use. Am I going to use the 2 cubed or the 2 squared? 2 cubed, because it says you got to use the highest power of each. This guy's out because he's only squared. He trumps him. He's 2 cubed. I've got a 3 squared and a 3. Who's out? This guy's out. I haven't even done 72 yet, but I already know this guy's out and that guy's out. Because this is a higher power of 2, and that's a higher power of 3. You with me so far? Three, 2 cubed times 3 squared. I have a 2 cubed here, so I'm using 2 cubed. I'm not going to use it twice. It's the highest power of 2. So what's my lowest common multiple? It's 2 cubed times 3 squared, 3 squared. I'm not going to use it twice, just once. So 8 times 9 is 72. And if I do my multiples of 24, you know that in 3 days is how many hours? 24, 48, 72. 36 times 2?
Yeah.
72. So 72 ends up being my least common multiple, which we can do and check it. We got there by the highest power of 2. This was a 2 squared, so we don't use it. 2 cubed is what we have to use because, what's it say? The product, multiply them together, of the highest power of each prime number. I'm still getting blank faces. Before we get to the monomials with the letters, let's just keep doing this. We'll practice these. We're going to do numbers 8 through 19. 8 through 19. Let's go. Maybe. 8 through 19. Yes.
On the thing you multiplied, like, there was one of the things with 4 though.
Where? 4 is not prime.
Oh, wait, oh.
Factors of 4, prime factors, 2 squared, 2 times 3. Which 2 am I going to use? The one that's squared. So, and I have to use the 3. So it's 2 squared times 3. 4 times 3 equals 12. How many? You were able to easily look at 4 and 6 and say, oh, LCM is 12, right? Right?
I had to do the word.
6, 12, 4, 8, 12. 12. 2 squared. This guy's gone because there's a higher power here with the 2. So it's 2 squared times 3. Getting there? Number 9, 6 and 21. Is anybody upset that I'm doing it this way now instead of the tree?
Yes.
2, 3.
Next time, 7.
3, 7.
Yes.
Watch. I've got it. Over here I got 2 times 3. Over here I got 3 times 7. I have to use every prime factor to its highest power. So I got to use a 2, I got to use a 3, and I got to use a 7. So the LCM is 42. Does that make sense? 6, 12, 18, 24, 30, 36, 42. 21 times 2 is 42. 42 is the LCM. I have to use every prime factor to its highest power. Get it? No, you don't. You're just saying that. 8 and 10. What's gonna be my answer? Do it in your head. 8 and 10. What's gonna be my least common multiple? Don't you dare say 2. It's a factor.
For which one? 2.
For 8 and 10, 40. 40. 10, 20, 30, 40. 8, 16, 24, 32, 40. First one you come to is 40. How do we get there using prime factorization? Two times 4, 2 times 2. Which 2 am I going to use? I've got 2 cubed over here and 1 2 to the first power with the 10. Which one am I using?
The highest one.
I got to use the 2 cubed. 2 cubed. Do I have to use the 5?
Yes.
Wait, 5's not in common, Spence. Do I have to use it?
Yes.
Yes.
So I'm...
Yes.
Maybe, yes.
I got to move your hand.
Yes.
Yes?
No, I'm saying yes for the answer. Yes, it's 5.
I have to use 5?
If you say something-
Even though it's not common.
Yeah,
Yes.
Even though it's not common.
it's not common.
I have to use all the prime factors to their highest power. When I'm trying to find lowest common multiple, I don't worry about them being common. When I'm trying to find GCF, I do worry about them being common.
Yeah.
8 times 5 is 40. Dina, are you done with number 11?
No, but I actually got one more.
The lowest common multiple between 10 and 15. 15, 30, 10, 20, 30. I know my answer going in is going to be 30. Let's see if this stuff really works. 2 times 5, 3 times 5. I got to use all 3 of them, the 2, the 3, and the 5, because you have to use all prime factors. Ends up being 30. Number 12, 36 and 90. You think? That's a common multiple. Is it the least common multiple?
No.
No. What?
Okay, watch. 4 times 9, 2 times 2. So for 36, I got 2 squared times 3 squared. I don't know if I'm using either one of those yet. I know I got to use a 2 and a 3. For 90, I get 3 squared times 2 times 5. Am I going to use a 2 or a 2 squared?
2 squared.
I got to use the 2 squared. I got to use a 2, a 3, and a 5. I got to use all of them. I'm not using this guy because I have a squared over here. Am I going to use 3 squared or 3 squared?
3.
Uh-huh.
The middle.
Do I have to use the 5?
Yeah.
Got to use them all. 4 times 9 times 5 is 180.
Lucky you got
All right.
I said
Mental. I see what you did there.
I see what you.
one.
17 and 57. Ooh. This could be a hard one. You already done? You're going, oh. Here, I thought you were going faster than me.
Sorry.
You just want to escape. No, I'm just kidding. 17 and 57. Seventeen is prime. I don't know any times tables to go to 57, but I do know 5 plus 7 is
12. No, 7.
12. So I know 3 goes into 57. I just don't know how many times yet.
Oh.
So somebody tell me, how do I find out the lowest common multiple between 17 and 57? My prime factors are 17, 3, and 19. How am I supposed to figure out the least common multiple? Noah,
17 times 3 times 19.
I gotta use them all. I gotta use all the prime factors, and they're all to the same power. So I gotta do 17 times 3 times 19. 51 times 19. Tell me what you got.
669.
No, I know that's not right.
$969.
That sounds closer.
Yeah, 969.
I know, I'm trying to do it in my head.
It's 969.
I can click that.
Yeah, it's
969.
I cannot.
51, yes.
Yes.
1020 minus 51. 969. 969. 17 times 3 times 19. Number 90 and 108. Dominic?
720.
Dominic thinks it's 720. What do you want to start with, Noel? 9 and 10? Prime factors of 90. 2 times 3 squared times 5. Everybody's at least knows this, right? Do
Yeah.
prime factors?
Yeah.
Prime factors of 108. Oh boy.
254.
Wait, times tables, 9 times 12.
108.
Or you could do that. That's fine.
3 times 3,
13.
3 times 4, 2 times 2. Prime factors of 108 are 2 squared times 3 cubed times 4. Okay, which 2 am I going to use? I have to use every prime factor. Am I going to use this guy or that guy? Evelyn, that guy. I'm going to use, because it's a higher power. I got to use the 2 squared. You're gone. Am I going to use 3 squared or 3 cubed, Zacchaeus? You're gone. Am I going to use 4?
Yes.
Am I going to use 5?
Yes.
Yes.
So 4 times 27 times 4 times 5.
That's a long.
So we got
20
80 times 27.
What?
What'd you get?
Oh, yeah.
80.
What did you get? Wait a minute, wait a minute.
That's
I messed up somewhere.
How'd you get 4?
2160.
Yeah, how'd you get a 4 and 27 and another 4?
What is that?
2160.
What is
Yeah,
that?
that came from nowhere.
Yeah.
4 is not prime.
Yeah, thank you, Bella. How did that happen?
Well,
That's, Very strange.
I wouldn't say that. I mean, I wouldn't say that. I wouldn't say.
All right, so what do we get? Did I still mess something up?
Yeah, no. Now this one is support power.
What? You should have three cubes times 2 squared times 5.
Wait, time out, cut! Cut. 108 is 3 squared, or 3 cubed, and 2 squared.
Yeah, you're right.
And here,
You're right. Yeah, that's
2 times 3 squared times 5.
That is correct. That is correct.
So I used the 2 squared, I used the 3 cubed, I used the 5.
Yeah, that is, yeah.
So what do we got?
I don't know.
Yes, I thought you were gonna give me an answer. What do we got?
4 times.
540.
Oh, I did that, man.
Well, you didn't offer.
I'm insane.
540.
I'm insane.
125 and 500. What is it? Before we start this, what is it? I want you to be able to look at 125 and 500 and tell me what it is before you even start.
500.
500. Because I want you to recognize that 125 goes into
Oh,
500.
we're doing that. I thought we were. I don't know.
Okay, prime factors of 125 and 500. Isn't this fun?
Yeah.
Listen, just make it fun. Change it up. Don't do a tree. Do this then.
No one likes that.
I hate it, man. We got back to that revision.
So, hold up. What makes 125? 5 cubed. 500. One, two, 3 5s. 2 squared. Which 5 am I going to use?
The right one.
Doesn't matter, right? 5 cubed
Use the right one now.
times 2 squared.
Keep your house.
That's number, is that 15?
Yes, sir.
6, 8, and 12. Too many conversations going on, especially since this is something that we're not grasping right off the bat. 6, 8, and 12. In my mind's eye, I've got 6, 8, and 12 being 24. Anybody with me?
Yep.
The least common multiple for those 3, 12, 24, 6 goes into 24, 8 goes into 24. Well, let's check it by using prime factorization. 6, 8, and 12. So I've got 2 times 3, 2 cubed, and 2 squared times 3. Who's out of here? This guy's out of here, and this guy's out of here. Why? Because I have a greater power of 2. That's the one I'm going to use. The 3, I only use once. 8 times 3, 24, just like I thought it was going to be.
I think I get it.
You think you get it now? Keep going. Number 17. Are you doing these? You're not doing them.
No, I did them.
You're just counting on me to do them.
No, I
8,
didn't.
16, and 32. Jaden says, I know the answer is going to be 32 because 8 and 16 go into 32. But we got to prove it. Zacchaeus, you're not doing it either.
I did.
That's called LAZY.
Yeah.
That's called Mr. Franken's doing it, doesn't have to, and you're not, but you have to. No, did it really? Just through 19. 8 through 19.